I'm going to talk about logical decoding. This is a talk that was already happening last year, but I want to give it from I want to talk from a different perspective. The perspective I want to focus on is that this feature in Postgres that came in Postgres 9.4 is basically enabling a new, what I say is a new world of applications. It's basically an open gate, it's like a door, to create new applications to integrate Postgres with. It is a way of extracting all the information out of a Postgres database and putting it into external systems. So we can do many sorts of things. We're gonna see how it works. But so in my opinion, this makes this feature one of the most relevant, if not the most relevant feature of Postgres 9.4. I think it's extremely, extremely important. And basically allows you to integrate the changes of the information to happen to Postgres into different data sources. A little bit about myself before. I'm just basically, as Joe said, from 8K Data. 8K is a company devoted to research and development in databases. So we try to do crazy stuff. And some of that stuff turns out to be sometimes a product or something that is interesting. We do a lot of open source. So far, everything we have done is open source. And well, we are also the founders of the Postgres, the Spanish Postgres user group, which is now the 5th largest Postgres user group in the world. We're around 500 people, which given the population of Spain is pretty good. And this is my LinkedIn, Twitter handle. If you wanna take a picture of me and tweet that, I'll appreciate that because my friends are watching now the stream because they don't believe I was going to do the talk with my cowboy hat. Okay, so logical decoding. First of all, one slide. What is this? Basically, the idea of logical decoding is a way of extracting the changes that happen to a database, that is, insert, update, delete, and throw them away, give them to an external system. But just the changes, like the diff, but data diff, if you want to think of it that way. The changes are generated per row. So even if you do like a update I equals I plus 1, and that affects like 1,000 rows, you'll get 1,000 changes, saying I equals 9, I equals 10, I equals whatever. And they are ordered. They're strictly ordered in commit order. Even if concurrent transactions are happening, at the end of the day, there is a commit order. And the changes are going to be produced in exactly this order, the commit order. And well, as I was saying, the main goal of this is to replicate the state of the database. As long as we are pushing away from the database these changes, every change that happens to the database, to the data of a database, we can take out of these changes and reproduce them externally. We can take them to an external system and reproduce the state of the database, the whole state of it. So, for example, we can create replication solutions. If I recall correctly, this was the initial goal of logical decoding, to enable for logical replication solutions. But also other options, other features like we have like materialized databases. So, for example, you say you're running Postgres, as I hope you are. But then you want to, let's say, get a specialized database for processing part of your queries, part of your data, or the whole data set. So with logical decoding, you're going to consume those changes, put them onto a different database, and effectively materialize the state of the original database into a new database. And that database may be specialized to some type of queries. So you are live getting the changes out of your database, put them on that materialized databases, and getting the benefits of that specialized database. One good example of this is pushing data to a data warehouse database. So you can do distributed queries and so on. And of course, you can basically create any third-party kind of processing applications that you want, even applications that don't need to store data. Some applications that maybe do real-time processing of data, of the diffs of the data you obtain from the database. So this is basically the whole idea about logical decoding. Let's see how it works. The basic concepts. Well, if you go back to the Postgres documentation, which is a really good source of documentation for Postgres, basically what it says is that the logical decoding is the process of extracting all persistent changes to a database tables into a coherent, easy-to-understand format. The format is also a very important thing because the format is logical. And logical means that it's not tied to the physical representation of the database. It's not tied to a particular version of the database. It's not tied to an architecture in which a database is running. It is an database independent, version independent format. And indeed, we can control this output format. That's also very good. And it is, well, as it's saying, it is interpreted without detailed knowledge of the database internal state. We don't need to understand what was there, what is the architecture, so on, in order to interpret these changes. So as I was saying before, the changes are decoded row by row, even though the SQL command that created that data change were affecting like many rows. And only tables, as we're going to see, this depends ultimately on the WAL files, the durability mechanism for Postgres. And as such, anything that is not logged will not get decoded. So you will not get logical decoding output. You will not get the changes that happen, for example, on temp tables or unlocked tables. But this is, of course, usually not a big problem. As of today, only the changes to data are decoded. So there's no DDL decoding. This is, I don't know if it's going to happen soon or not, but there's a kind of easy workaround anyway. You can use the event triggers, if so you want, and record the changes that happen to the DDL and put them on a normal table under some convention. And then as long as it's a normal table, the changes will get decoded as normal data changes. So it's not a big deal as of today. Most applications won't suffer a lot without DDL not being decoded by logical decoding, but you can work around it. This is, for example, what is happening on BDR, which is using this technology. Correct me if I'm wrong at some point, please. But any DDL changes are logged to a special table. I mean, it's a normal Postgres table with a special naming convention. And then those changes are, of course, logged with logical decoding as part of the normal process. It requires, this is pretty logical, it requires either super user or replication permissions, because after all, we are reading the whole contents of the data that goes to the database. So we require super user permissions, or at least replication permissions, which are basically the same thing but tied to replication. We cannot do without. And it is very important that logical decoding relies on the logical replication slots. The logical replication slots, if you're not using them, which you probably should, is a better way of controlling the resources that the database is holding for the replication process, or in this case, the logical decoding process. Basically, if you say, Maxwell segments, that's a kind of indirect measure to control the number of WAL files that are going to be kept at the server, which means the disk space that your pgxlog directory is going to take. And as I was saying, it's a little bit indirect because you cannot say, okay, I want to keep the changes for the last few hours, because you don't know, unless you know very well the data change rate and so on. The slots are a better way of handling that problem. Just basically, you're going to say, okay, I want to keep all the data changes that happen to the WAL files from this moment in time until I consume them, until I have read and processed them. So the server the Postgres, will basically open a window and keep the data in the window for you. So logical decoding works on top of the logical replication slots. So you create a logical replication slot, and we're going to see how to do that. You create a logical replication slot, and from that moment on, you're warranted that the Postgres server will keep for you the required WAL segments required for doing the logical decoding itself. And as long as you will be consuming that data, that window will be moving, and Postgres will be able to release those resources that have been reserved for you by the means of using the logical replication slot. As I was saying, the format of the data is controlled by the output plugin. That's the name it's called. So the good thing is that this format in which I am given the data, the data change, is controlled by the user. So you can say, when I have whatever format in which the data change is going to be given to me, and you can create plugins. And this is good news. There's a default plugin that comes in the contrib module, which is called test plugin, test output. And it's available mostly for testing purposes, but it produces a text output, which can be parsed if so you want. And it contains basically the information you may want for the logical decoding process to be useful for these external applications I was saying that you need before. But you can create your own plugin. It's a very simple method. It's not a big deal. This test decoding plugin is around 500-600 lines of C code. You need to program that in C. But again, you can do that. You can write your own plugin. We'll see there are some plugins already created for Postgres, but you can create your own. And it's loaded dynamically. And so it's discovered by Postgres. You can just copy the shared library and create a slot with this plugin, and the data changes will be transformed by your plugin in whatever format you want. There are two basically ways of interfacing with the logical decoding process in Postgres. The first one is the SQL interface, and the other one is a Postgres replication protocol, the replication interface. The SQL is it's easier to use. It's very handy. It's mostly meant for testing purposes. It basically involves calling SQL functions, but it's more limited. It's more limited, first of all, because it's poll-based. You need to be calling the functions to see if there's any change to the database. And whenever you get the changes, you will get as many changes as were produced to the database since the last moment you call this getChanges function. On the contrary, the streaming replication protocol will push you the changes. So you can react to those changes. And this enables kind of asynchronous reactive applications that will be consuming the changes as they happen to the database, let's say almost real time. Apart from that, the replication interface requires you to speak the replication protocol. So that's the only problem or caveat that we'll see that is required. Also, the streaming replication interface is going to specifically export a snapshot. A snapshot is a consistent view of the database. So as long as you create the connection to start streaming, start getting the logical decoding via the replication interface, you'll also get a snapshot identifier, which you can use to open a new transaction, a new connection, and set the transaction identifier to the identifier you got, and you can have a consistent view of the database. We'll see how this is very useful later. So, how to configure logical decoding? It's very, very, very easy. Basically, you only need two parameters, which is what level. What level, there's a new value, which is logical. This is required for logical decoding. It adds more or less a small overhead. I don't remember the numbers, Anders, if it was like.
Depends on the workload. If you
sure, it does.
do only inserts, there's basically no overhead. If you do updates, there's an overhead if you change the primary keys. And if you do delete, there's always a bit of overhead because we do remember what the primary key was that was deleted. Unless you said there's some part later.
Yeah, the replica identity. So, well, there might be some overhead involved, depending on your use case. It's usually not very significant. And so, first of all, you need to set wall level to logical, and then set the max replication slots. How many slots do you want to create? By default, the number is 0. Both changes require you to restart Postgres. And then, optionally, if you're using the replication interface, you need to set up the max wall senders parameter, as the same case if you're doing replication, how many clients to the Postgres replication interface you want to have. And also, of course, you need to set up replication connection, replication authorization in pghba.conf. Exactly the same thing as you would do if you want to do replication with Postgres. Nothing new on the table. And finally, you may want to tweak synchronous commit if it's not set to, or just understand that if synchronous commit is set to off, the decoding process will also be delayed. So you'll get the changes potentially delayed. If you want those changes to be decoded as synchronously as possible with the data change itself, you need to set up synchronous commit to on. So how to interface with the data changes? Let's see this hopefully working. As I was saying, the SQL interface, you just call some SQL functions and get the changes. So the functions are similar to these ones. The first one is PG create logical replication slot. With this function, you'll basically create a slot. You have to give a unique name to the slots. You just set up a name, and you specify the plugin you want to have the output transform. So I was saying the test decoding plugin, this exists in the contrib module, but you can also install any other plugins or create your own. This is a set returning function. It will return basically some fields regarding the slot. Sorry, a record returning function. And once we have created the slot, we can just basically, since that moment on, all the changes that happen to the database will be recorded, or will be, let's say, decoded some later time. And we can get the changes with PG logical slot get changes. Let's try to quickly see this running, if it hopefully works. Can you read this font somehow? Let me just adjust the window a little bit. All right, is that font okay? Okay, so let's connect to a given database. And so first thing that we need to do is to set up the required parameters. I think they're not set up right now. So let's say wall level. Yeah, okay. Keywords in Spanish. So wall level is minimal. We also need to set up max replication slots. And this is also going to be 0. So let's change this first. Let's use the facility alter system, which is also new to Postgres 9.4, if I recall correctly, to change Postgres parameters. So let's say alter system set wall level to logical. And also let's set the max replication slots to, let's say, 10, any number basically greater than 0. And now let's restart Postgres, because both parameters required to restart Postgres. Let's connect again, check that the parameters are correctly set. Yeah, okay, so now we should be able to create a replication slot. In order to do that, as I was saying, we just need to call the function pg create logical replication slot. Names are a little bit long sometimes. We give a name to the slot, let's say A. I'm not very original with names. And we specify the plugin. In this case, I'm going to use the test decoding, the one that comes with the contrib module. And then we create the slot. So now that we have created the slot, we can start streaming the changes. Well, not streaming in this case, because we're using the SQL interface and it's poll mode, but it can basically poll for changes. So let's do that. Let's say select star from PG logical slot get changes, and then I specify the name of the slot and 2 other parameters. I'll explain later what they mean. There are no changes right now in the database because I haven't done anything with the database. Let's do that. So I'm going to open another session, and let's say create a table, EU, with EU integer, for example, and let's also say, well, I was saying before that there's no DDL decoded, so let's try that. This is already changed to the database. If I try to get the changes, there's a transaction. I can see that there's been a transaction going on, but there's nothing in it because there were no data change. Now, if I produce some data change, like an insert, whatever. I know this is not a very interesting example, but anyway. I can see now that there is effectively some changes decoded here. Here I can see that there's table public.eu. Sorry, I'm just going to point with a pointer. Public.eu, there's an insert command that says insert in field column EU, which is an integer, value 8. This output, this text here, is what is controlled by the output plugin, this test decoding. If you want to have something different here, you want to have a JSON, or you want to have whatever, you can use different plugins, or you can write your own. So this is the logical output. where it's not dependent on database version or architecture, and it's controlled by you, or by the plugin in this case. So as you can see, this is a very simple process. We just need this wall-level parameter in PostgreSQL.conf and the max replication slots. We create then the slot, and we start consuming the changes. Any questions so far?
When does the data disappear? I mean, it's already committed. You've got synchronous committed in this example.
Okay, so using the SQL interface, so Postgres for logical decoding requires a feedback mechanism to basically tell the server when you have consumed the changes, and so that those resources can be released. The slot will move the pointer, will move the window. With the SQL interface, it is just controlled by the SQL function. So we're just going to see it afterwards, but there are two functions. One is get changes, and the other one is pick changes. Get will consume as soon as you call the function. So if I call get again, we'll see that there are no further change. But there's another one which is called pick. Let's do that. So if I use, rather than get, I use pick. You can see down there, right? Well, anyway, if I say pick, there's no changes. But then if I insert another value, now there's the change here. But as long as I'm calling pick, it's not going to be consumed. So I can pick it anytime I want. OK, so this is the mechanism to create the slot. This is the mechanism to get the changes out of the replication, logical decoding process. As I was saying, there's a get versus pick function. We have seen how it works. There's also the option to add the underscore binary to the function name, in which case we will get the output as a binary. This is only useful if you have a plugin which declares its output to be binary format too. Otherwise, you're just going to get a byte A of the text representation, which is not very useful. But if your output plugin is outputting binary, well, you should probably be consuming this. I'm sorry, I'm going back and forth. Sorry, OK. What about the extra arguments to this get and pick functions? So the two nulls that we were having here, the second argument, basically, it's the up to LSN, the last sequence number. So it's basically a way to control how much, both arguments are used to control how much output you want to have decoded while calling the function. This first one, you specify an LSN, which is a way of specifying a location on the wall stream in Postgres. It's a little bit low level. But basically, you can say up to this number, and you'll get decoded up to that transaction. And number of entries, you'll get the number of entries up to that number of entries. However, neither of these are very precise because this cannot cross the transaction boundary. So you'll get decoded full transactions anyway. Even if you say 10 entries, if there is a transaction with 15 entries, you'll get 15. So it's not very precise. You cannot cut a transaction. That's up to your application if so you want to do. And then you can also specify some extra arguments, which are very interesting in some cases, which is they are plugin dependent. So plugins can also declare that they have options. And you can set these options when consuming the changes out of the logical decoding. And you can say, for example, in the test decoding plugin that we are working with right now, you can set either include timestamp to on, which is not the default. So it will include in the output the timestamp of the transaction that's being decoded, and include the XIDs of the transaction, the transaction identifier, which is by default set to on. Let's see this as in a quick example. So what I'm doing right now is this. If I just add another option here, which is include timestamps, I believe it's in plural, right? No, singular. Include timestamp, and they will say 1. Then you can see here that it included the timestamp in the text of the decoding output. I can also say include XID to off, and then this information, this is the transaction ID, will not be printed out. That's also interesting because I have the XID there anyway. So, but again, these are options that are controlled by the plugin itself. So they are plugin dependent. Okay. So this is SQL interface. It is very important to understand what is the slot life cycle. When they are created, how much do they last, and so on. Because basically, the slots are a mean of retaining some resources which might be needed for the logical decoding process to work. So first of all, when you're done using a replication slot, the first thing that you have to do is drop it. In this case, you're going to be releasing potentially resources. How to drop slot? Just call another SQL function, pg drop replication slot name, and you're done. Because if the slot is not consumed, if you're not calling get, the wall segments, the wall files, the wall chunks required for decoding the information, that's going to be retained. And that's going to be retained forever. So basically, if you never consume the changes, if you create the slot and never call get, your pgxlog directory is going to grow and grow and grow. And I'm sure you all know what happens if this directory fills completely. Basically, your database stops. And that's not very nice. So one of the important caveats while using logical decoding is make sure the slots are being used. So if you have an external application, it can be external to Postgres, of course, and that application crashes, well, it's never going to consume the slot. So you better monitor those. So first important takeaway, always monitor the applications that are consuming the logical decoding process. It also has some influence on vacuum and catalog tables because the logical decoding process may consult those, and as such, they cannot be fully vacuumed until those resources are perfectly released. So it's very important to make sure that you consume the changes and that you drop the slot once you're done with it. Yeah?
Oh, you might be getting there. Is there a view where you can see what the...
Yeah. Perfect timing for the question. So there are a couple of views that are relevant to logical decoding. The first one is PG replication slots. It's going to give you basically which replication slots are available and which position they are on, which is the plugin used. And if you're going through the replication interface, you also have PG stat replication, which gives general information about replication. And as long as logical decoding can be consumed via the replication interface, you'll find also relevant information here. Let's query the first one, which is in case the one we're using right now. So if you go to, yeah. Makes this easier to read. So basically here, we have slot A, the plugin is test decoding, it is of type logical, it can be also physical, there's also physical slots in the database. The database, where it belongs to, and so on. So yes, there's a view for that. One important thing, let's also demonstrate this. So we've been reading the changes. Rather than insert, let's do an update here. So if I say update EU set EU, right? Yeah, equals to EU plus 1. Works, and then if I get the changes, let's get them rather than pick them in this case. Well, what I see here is that there's an update to field EU, but basically I don't know the previous value here. So in order for logical decoding to be probably useful for most applications, we'll kind of know the key of this row, if there's any key, the primary key typically. Or some means of identifying which tuple is being changed. Because if we want to reproduce the state of the database into a different system, we might need this. If we're just doing real-time processing, it's okay. We might not need that key. We're just analyzing the values. But if we're fully reproducing the state, we may need that. So this is controlled by another feature, which is called replica identity. Replica identity is basically what information is going to be added to the wall files, which is going to be eventually decoded by the logical decoding process to basically identify which tuples have been changed. So replica identity is a table parameter, so you can set it at create table time or alter, or you can do an alter table to change it. And it has this value. So basically the default, it will basically output, or to be more precise, it will deliver to the plugin the information of the primary key, if there's a primary key. This table didn't have a primary key, that's why there's no extra information. If set to full, it will return all values, and this is the one that consumes the most that impacts the most the overhead of using logical decoding. It will basically say output all the old values and, of course, all the new values. If we set it to nothing, it will do nothing, no values, no old values. And if we say using index and then an index name, an index which cannot contain not nulls and cannot be a partial index, it will output the old values for those values covered by the index. You probably could be away with using default or using index, because you probably are good with just identifying the tuple by the key. But you have the freedom to do it. So in order to show that this works, let's just say alter table EU set replica identity full. And now if I just do the change again, and then get the changes from the logical decoding, I will see that now I say old key and new tuple. Now I did set it to full, so it will return the whole old tuple, the whole new tuple. But basically, I can get the same happens with the delete, of course. This applies only to update and delete. So with the replica identity parameter, I can control how much output will I have on the logical decoding process for updates and deletes.
And that's independent of plugin.
Yeah, and then the plugin will decide whether to output that information to you or not, and format in one way or another. This controls what information is given to the plugin. The output we've seen is just from this test decoding plugin. And yes, it prints as text this information. So we've seen the SQL interface. Now let's move on to the replication interface. In order to use the replication interface, well, bad news, you need to speak the Postgres replication protocol, which I'm sure you do, or you don't. Well, there are some applications that do, but it's definitely not commonplace. One option to basically debug this, you can trick pSQL to speak the replication protocol. If you basically pass a connection string which specify replication equal to database, this will trigger. Well, at least you can create a slot with this. Yeah. Yeah, not all commands. Yeah. So it's basically the debugging mechanism. But you need to speak the replication protocol. This is replication protocol. This is a replication protocol command, which basically creates the slot. Fortunately, there's a client program, external program to the database, which is called PG Receive Logical that ships with Postgres and speaks the replication protocol. So you can run logical decoding as an external process under the replication protocol, which means you're going to get the changes pushed in real time. Well, we're going to do a quick example on this, but there was a question before.
When you call the get application, can you go back to your terminal?
Oh, yeah.
So the call for this function is what triggered the full decoding of the wall into the logical text-based thing, right? So this one took 1.8 milliseconds. Or sorry, 1.8 seconds, right, for a single update. Is the test decoding plugin just basically a wall parser?
Well, if you're caring about performance, I'm pretty sure that Andres is going to be very happy answering that question. I told you, right? This is very slow, but I don't know why exactly.
You haven't updated, that's the issue.
Mm-hmm.
That's an issue with fsyncs, it's the Mac, right?
Yeah, but it's running Linux.
Yeah. No,
It's a Linux kernel.
I think you just need to update Postgres. There was an issue where fsyncs didn't
Yeah, it's 944, I believe.
I would need to look at it, but normally it should like take much further than this. I haven't looked up. Sorry.
We'll down under the replication interface. It's way faster.
Okay.
It's almost immediate. So,
The other one, right?
yeah,
The
yeah.
Is the decoding also done in parallel? If I have like how it's there? Like I mean.
What do you mean in parallel?
Like there's like 500 lines of wall, right? And like would it
For a given slot,
for a given slot? Yeah.
correct me if I'm wrong, it's serial. However, if you create several slots, that's going to be processed by several processes. Different processes, different backends.
But like I've run PG bench with 48 lines and it could keep up.
Okay.
So far it hasn't been.
Does it randomize, the writes to the slots, or does it always start in a particular order?
I'm not sure I understand the question.
Well, if you have 5 slots,
No, all of them get overlaid.
they all simultaneously?
Yeah.
Because like you might have like 5 replicas and each of them should get all data.
Right, but
You don't want the replica one that has only data starting with A and another replica starting with B.
Think of the slot.
You can make that kind of decision in your plugin if you want to, and just say this table doesn't interest me. I'm skipping doing anything.
Yeah, just think of the replication slot as a moving window with kind of a pointer saying, okay, I've read up to this point.
right, but if a tuple hits a table, it's got to send that information to 5 slots, say.
No,
It's not needed to send, so that tuple is going to go to the wall files. And when you're consulting the logical decoding, you're basically saying, okay, please decode these wall files.
So they're all competing.
They are there. Well, yeah, they're competing for reading, but it's going to be on buffers already. So I don't know.
it's all in memory.
It depends. The wall files may or may not be in memory at the time you ask for them.
Well, that's if you're doing streaming replication, that should be.
I don't know if there's any warranty regarding that.
If you have like if your standby is down for 3 days, you can't store everything in memory, so everything will get spilled to disk. So, but if you have like if you are keeping up, it will almost always be so. So unless you like have super high memory pressure.
I'm wondering why you're not co-presenting with me this. Because I'm always asking him these questions during the talk. Well, indeed he is.
And the wall is flushed only after every slot string, right?
The wall is?
Flushed only after like you will hold the wall until every slot string.
Well, yes. It's not flashed. It will be released for potential reuse after all the slots have, yes, consumed that.
You have like one poly wrapper.
That's why it's very important to basically consume the changes.
So an outside process has to do the consuming.
Yeah. That's why I'm saying, please monitor your external processes. If they crash, your database may end up crashing too. It's that hard. All right, so let's get back to the PG receive logical. So you want to speak the logical replication, the replication protocol. So you have this external tool, which is called PG receive logical. So let's use that here. So say PG receive logical. I specify slot name. Let's say slot, it was called U. I can also create a slot here. Just look at the command line options. Specify the database. This case is AHT. And I say, okay, stream to whatever file. I can use this standard output. Oh, let's say start. So I need to say start streaming. And I specify -f, the output file. You can see it can be standard output. So, oh, sure. We need to tweak the replication configuration first. So let's give us power for doing this. If you remember, this is basically replication stuff, so nothing new on the table. Let's, well, probably this should work. And we may also need to set max wall senders. Yeah. let's restart Postgres for this. And hopefully, we will now be able to. Oh, OK, yeah, sure, local connection. To change the HBA, we'll need to reload Postgres. Should work now. There is no replication slot U. OK. It's A? Oh, OK. Thanks. A. Now let's do some change to the database. OK. Let's connect it again. Now. And here we see the decoded output. Let's try to do this. It's almost immediate here. The good news here is that the changes are being pushed to us. We don't need to request them. As soon as they happen to the database, they are decoded and sent via the replication protocol. And we get the information there. So this is kind of real time.
I assume PG receive local is consuming automatically.
Yeah, it is consuming. OK, cool. So this is the replication interface. And now let's get to the interesting point. What this feature enables us to do. As you've seen, it's pretty easy to use it, either by the SQL interface or by the replication interface if you use PG received logical. Now, what this brings us is, as I was saying at the beginning, kind of what I call a new world of applications. Applications that basically are going to be consuming all these data changes and are going to do something with those. As I was saying before, it's primarily or was originally designed for or with replication in mind. Like BDR, EDR, these projects are using logical decoding. It was a basis for them. So in order to replicate the information to other nodes. There is not really maintained right now, but there's a development branch of Sloaney, which is going to be using logical decoding. And hopefully others. So every replication solution is very welcome to use logical decoding as the basis for its procedures. But it's really much more than this. And here's where the power comes. Like, for example, I can extract the data from Postgres and reproduce this in other systems, like materializing a given database. But I can also create external systems that will take this information and take decisions on the changes that happen to the data. Like, I don't know, as I was saying, any real-time application that is monitoring for fraud. So you're processing credit card transactions, and then you detect fraud, and you react on that. So it's a completely external application, doesn't need to be running Postgres, doesn't need to be querying whether there's been a new insert to this table. The changes will be pushed to the application will detect fraud and take an action. There are some output plugins, which as I was saying before, the output plugin, you can create your own. It's very simple C code, but there are some output plugins that are already available. So we have the test decoding, which is included in Contrib in Postgres, the one we've been using so far. There's also Decoding Raw by Michael, which basically decodes to SQL. So it kind of returns equivalent SQL commands that the one that generated the changes. There's one called Decoded Buffs that decodes to protocol buffers. So when I use protocol buffers to integrate the changes into another application, you can use this output plugin, binary format. There's another one which outputs in JSON, so wall to JSON. And there's one which is very interesting to me, which is called bottled water. And this one, what it does is decode in Alvaro format, another binary serialization format for Postgres, for general serialization, and then pushes these changes to Kafka. Kafka, for those of you who don't know what it is a distributed queue broker / whatever that is massively scalable. And it's very interesting because this one enables type of queuing architectures where you can push the changes out of the database to this queue and then consume from this queue from as many clients, as you want to. And this is the point where I want to really get at, event sourcing. So, event sourcing, this pattern, basically the idea of event sourcing is capturing all the state changes that happen to a given, let's say, source of truth, which hopefully it's going to be Postgres in your cases. And now reproduce them somewhere else and do whatever with those data changes. In typical applications, in architectures that don't use event sourcing, when you do a data change to a given part of the system, the actor that it's producing that change, it's going to have to go through every other consumers of that information to tell them, hey, I haven't updated this. And this is already difficult because the producer of the information needs to be aware of all the users of that information, of all the consumers of that information. Plus, it probably needs to do that atomically in some way or transactionally. And that's a pain. If you want to add another consumer of the information, and I'm going to show you that there is typically in big architectures a lot of consumers, you need to change the code for the producer. This is very tightly coupled. Event sourcing allows you to introduce new architectures, new data architectures that are very loosely coupled. So, for example, you can extract your changes and say, OK, I'm going to push the changes to a queue, and so that the queue will be consumed by other consumers. Or you can use, for example, this mechanism for cache synchronization. So rather than programming triggers or doing weird stuff to update your in-memory cache, you'll just let the cache consume these changes and decide to add new values or replace values or delete values or invalidate or whatever. You can do real-time processing. So you can have an in-memory database, which is going to be a side database to your main architecture, but you can do real-time stuff on your database. You can audit systems. So rather than doing auditing with all the tables or with external systems or plugins for Postgres, which is a good option, but definitely this is a really good one because it's completely external to the database. You don't need to change the database for anything, yet you're having all the information that happened to the database. You can audit that. Or of course, you can do logical replication, which was the original means for this technique. And this is a good example of this kind of architectures. This is the architecture that runs LinkedIn. They were kind of the first doing this. And this is what bottled water do. So imagine there's a web application here. And you do an insert to this web application. Now, with this insert, you want to do many things. You want to, let's say, create a text index and Elasticsearch or whatever. So you can do a text search on this. You want to invalidate or update your cache. You want to push this to Hadoop for, big data type map reduce jobs. You want to do monitoring on this to prevent fraud. You want to insert into SAMSA for some kind of, reports that you want to generate. So you want to do all these things. Now, if a new system comes in a traditional architecture, you're going to have to change your web app to update all the systems. And this is a pain, and this is error-prone, and this is not atomic. With this architecture, you basically write only to one database, which is the source of truth. Then extract the changes with logical decoding. This output comes to a queue, to Kafka in this case. And then you can add as many consumers as you want to Kafka. The producer doesn't need to know how many consumers do you have, or what shape do they have, or what they do. So this is basically the idea. Now, if you want to create this kind of applications, these are the basic rules. First, implement the replication protocol. It's easy. Then you open a replication connection. You read the snapshot identifier. Then you open another connection. You set the transaction snapshot to that identifier, set the transaction to read only, and then you dump all the previous state of the database if you want to start from the very beginning. Basically, backup the previous information. And now you start consuming the changes and send feedback to the server. So,
Easy Dump 9.5 will have, you can pass a snapshot and it'll just do that, all that for you.
yeah. But if you're using PGDump, if you want to use an external application which does something else. But the principle is the same.
Yeah, if you're going to go to another database.
Yeah. And this is basically it. There are a couple of implementations of this protocol, the PQ in C, a Zalando project which is forking CoPG for doing that. And our company, we're working on a Java project. It's going to be open source at some point in the future. Some extra links if so you want.
So libpq has the
Yeah, I mean, libpq implements a whole replication
really
protocol.
have to write anything.
Yeah. And basically, this is it. I think we've run out of time for questions, but I'm going to be available for any further questions.
Sure.
mean,
You want to know who's doing selects.
oh, yeah, yeah.
Can you do that in the logical? I don't think you can.
The logical decoding only produce changes. So select, unless you're calling a function, will not produce any change. So, as I was saying, this is it. I'm going to be available if you have any other question. But I think there's no roadmap as of now.
Well, there's all the important support is in 9.5. There's an extension that what it does give you is the ability in an event trigger to log the text of the DDL statement in a canonical form.
Hmm. That's what I was saying at the beginning, some workaround.
And like you usually, it's not, you need to integrate this into whatever solution you want anyway, because if you don't synchronize the DDL in some way, you're going to have problems because if you try to apply it twice, you get errors.
Oh, okay.
You work with DML and there's some error issues and you want blocking potentially across several systems.
Okay, I really want to thank you for coming here, but we need to wrap up right now. So again, I'm going to be available for all the questions. Thank you. Thank you very much.